Welcome back, mathematicians. In this video, we are going to learn about the graph of cosecant. So unlike sine or cosine, we see that this is no longer a continuous function. That is represented in the domain. So it says x such that x cannot be equal to pi times k. And that last set of notation means k is an element of the set of integers. So k can be any integer, 0, 1, 2, 3 on to infinity, or negative 1, negative 2, negative 3 on to negative infinity. This is represented on the coordinate plane as vertical asymptotes. So we have one at negative pi, we have one at 0, which is the y-axis. We have one at positive pi, 2 pi, and it continues on forever in that same pattern to negative infinity and positive infinity. The range is going to be the absolute value of y is greater than or equal to 1. If you're unfamiliar with absolute value inequalities, what this really represents is that y is going to be greater than or equal to 1. And so that would be one of these curves that opens up, or y is going to be less than or equal to negative 1, which would be one of these curves that opens down. In other words, our y variable is undefined in between negative 1 and 1. What is interesting about the graph of the cosecant function is if I were to graph the sine function on the same coordinate plane, I would have x-intercepts everywhere you see a vertical asymptote. And I would have minimum or maximum values everywhere we have a min or max for these u-shaped curves. So my sine function would look like this. And some people do use the sine function to help graph the cosecant function. So everywhere I have a maximum for my sine function, it actually represents a minimum for the u-shaped curves. Everywhere I have a minimum for my sine function, it represents a maximum for those u-shaped curves that are opening down. The period is the length of one cycle of the graph, which in this case, the fundamental period is 2 pi. So we can see this as represented from 0 all the way up to 2 pi. And so we are including, in this case, a vertical asymptote in the middle of that cycle or in the middle of that period. And we need to have one complete cycle, which means we have to have one u-shaped curve opening up and one u-shaped curve opening down to complete the cycle. The general form of the cosecant function is y equals a times the cosecant of omega times x plus b, where values of a, omega, and b represent transformations of the cosecant function. A actually represents two different transformations. A represents the vertical stretch or compression. So the absolute value of A, if it's greater than 1, represents a vertical stretch. If it's less than 1, represents a vertical compression. A also can represent a reflection with respect to the x-axis if it is negative. To calculate the period, you're going to take 2 pi divided by omega. So the fundamental period of cosecant is 2 pi, divide that by omega, and you'll get your new period or the period for your specific function. If omega does not equal 1, it will represent a horizontal stretch or compression. And finally, b represents a vertical shift. If b is positive, it will be a shift up. If b is negative, it will be a shift down. We are now going to use this information to graph the equation y equals negative 2 times the cosecant of pi times x. So first, we'll start with any vertical stretch or compression. Because the absolute value of a is equal to positive 2, this represents a vertical stretch by a factor of 2. Because a is equal to negative 2, which is less than 0, then what we know is that there is going to be a reflection about the x-axis. Finally, we're going to figure out the period, and if there's been a horizontal stretch or compression, then the period will no longer be 2 pi. So we will take t is equal to the fundamental period, which is 2 pi, divided by omega. And what we see is omega is actually pi. Now, omega can be in terms of pi, and when this happens, we would reduce by pi to get a value of 2. So therefore, since 2 is actually less than 2 pi, there's been a horizontal compression. Step number 1 is to find the new vertical asymptotes given that there's been a horizontal compression. To do this, we're going to start with the domain of the original function, which was x cannot be equal to pi times k. We are then going to apply any transformation that affects the x-coordinates to this domain. So that means dividing by pi, since dividing by pi or omega represents the horizontal compression. Simplifying this, what we get is the new domain, which is that x cannot be equal to k, where k is an element of the set of integers. We are now prepared to find all the vertical asymptotes. To do this, we're going to let k is equal to 0, which gives us a vertical asymptote of x equals 0. Then k is equal to 1, which gives us a vertical asymptote of x equals 1. And then k is equal to negative 1, and this gives us a vertical asymptote of x equals negative 1. These three vertical asymptotes will actually give us one complete cycle of the cosecant function. I am now ready to graph the vertical asymptotes. Now what you'll notice is that my coordinate plane is not in terms of pi. You do have the ability to adjust the scale so that way it's in terms of pi or not in terms of pi accordingly, which will allow you to graph these more accurately. And so what I did was go by a scale of 1/2 for both my x and y axis. So I'm going to graph x equals 0, which is the y-axis, then x equals 1, which is a vertical line on x equals 1, and then x equals negative 1. And these are my three vertical asymptotes, which will allow me to graph one complete cycle of the cosecant function. I'm now ready to go ahead and put my min or max point of my U-shaped curves on the graph. Now to do this, those points are going to be the midpoint between the vertical asymptotes. So they'll be at an x-coordinate of 0.5 and negative 0.5. The U-shaped curve that is between the first vertical asymptote, which I'm calling the first one the y-axis, and the one to the right is going to be at positive 1 opening up. And so in this case, I am going to draw the graph, although this is not my final answer as I apply more transformations. The one between the vertical asymptote of negative 1 and 0 will be at negative 1 and it will be opening down. Step number 2 is to apply the vertical stretch. To do this, I'm going to multiply all y coordinates by 2. I will now have an ordered pair of 0.5, comma 2, and my graph will still be opening up but stretched out, and negative 0.5, comma negative 2. Step number 3, which is the final step, is to do the reflection. Because this is a reflection about the x-axis, this means that the y-coordinates will change to their opposite value, but the x-coordinates will remain the same. So I will now have a point of 0.5, comma negative 2, and my graph will open down, and negative 0.5, comma positive 2, and my graph will open up. Once you've established these two U-shaped curves, you can actually continue with the pattern, making more vertical asymptotes and more U-shaped curves opening up or down in a similar fashion. All right, guys, good luck.